Hello, everyone, and welcome back to another edition of Index Office Hours. Today is the 21st of May, and this is Index Office Hours 158. That is a big number, almost at 160. So, thank you very much. Thank you very much. We love a good round of applause. Really appreciate that. Um, For those who are new to Index Office Hours, this is the town square for ecosystem participants to come together and discuss the most important and relevant topics for indexers. This is a conversation that's going to be recorded and posted onto public channels like YouTube. So if you are concerned about privacy, please bear that in mind. And with that, let's get into today's agenda. As always, we do a shout out for the latest GRT IQ episode, and today is no different. Thanks for posting the links to the agenda and the GRT IQ episode, Juan. This is GRT IQ episode 169 with Mina Zhao. Hopefully, I'm pronouncing her name correctly. And she is the CEO at Native, which is a DeFi solution that combines bridges, assets, pricings into one offering. So it's like a unified DeFi interface that people can use. She has a very interesting background. She was involved in the world of data science before she joined the crypto space and has used some of her insights in data to tweet about that in her Twitter and also inform the creation of Native. So if you're interested in learning more about Mina, her background, and also the checking out the podcast, learning more about Native, then check out the podcast. Awesome. That is it for opening remarks. I would like to hand over to Anna for our regularly scheduled Repo Watch section.
Thank you, Abel, and hello, everyone. Okay, so today on Repo Watch, starting with execution layer client, we have had new releases for Firehose Ethereum. This is version 2.5.2, which is simply bumps substreams to version 1.6.2 and adds an environment variable for being able to disable file preloading. And we have another new version. This is version 2.5.3, which bumps Firehose core to 1.4.2. Then we have a new Arbitrum Nitro release. This is version 2.3.4, which lays the groundwork for Arbitrum OS 30. It merges the new upstream get versions, improves block validation, and improves EIP 4844 batch posting support. And this is all we have on the execution layer clients. On consensus layer clients, we have no new releases. And on GraphStack, we have a new release for Subgraph Radio, version 105 Alpha 2, which updates OpenSSL. I think this is in relation to memory leak. But yeah, this is all we have this week. Please let us know if you've tried any of the versions or if you have had any issues with them. So with that, over to you, Juan.
That was fast. Thanks, Anna. So getting into Protocol Watch, we'll first cover, as always, forum governance. For forum governance, we have 3 threads to take care of. First of all is BOVA BNB integration, which is, I think, a layer 2 for Binance, if I'm not mistaken. All of the details are in the thread if you're interested in, helping with the testing and the integration as a CIP. There's also support for Circuit Mainnet, which is a CK L2, as far as I'm aware, but it's EVM compatible. So it should be as easy as running any other EVM chain. So integration should be fairly simple, according to the thread. And there's a small update to the chain integration tracking doc, mainly for, I think, Linea and Scroll, which are in the latest stages of integration, waiting for the GGB, and taking care of all of the bureaucracy, so to speak, to add support on the network. But that's pretty much it for it. Next up, we have on forum research, we have the full catalog of all of the core dev update threads for May 2024. That includes GraphOps, Guild, Edge and Node, Semiotic, Messari, Geo, Pinax, and Streaming Fast. If you're interested in any of those, the links to all of those threads are in the agenda. As always, they are pretty lengthy, so we are not going to be covering them during this episode. For the contracts repository, we do have a small update to the Horizon story. There were a few PRs for Horizon merged into the Horizon branch. All of the work for Horizon is being basically aggregated on that branch, and hopefully, ready soon. I don't know when Horizon is going to go through, but there's a lot of progress on that branch at least. There's still some work in progress PRs for Horizon, as well as make the SDK and table printer as a dependency for contracts. But that's pretty much it for contracts repository. Moving on to network subgraphs, we have a small new release for the core network subgraph. As probably many of you know, last week we had an issue with the core network subgraph for Arbitrum, where there was an issue with pruning and stuff. So one of the measures we took to avoid these kind of issues in the future is for this particular subgraph, which is pretty critical for operations. We removed the pruning settings for it and just triggered a resync. This is version 1.1.0. Again, the code is pretty much the same. The only thing that we removed is the pruning settings so that we retain all of the history in case anything goes wrong with the syncing process and we need to do some rewinding or stuff and not have any issues with it. Then for the analytics subgraph, we don't have the release yet, but there's a promising potential fix which is close to being synced. Unfortunately, it does require a full resync, which takes like a week of resyncing. It's on the last, I think, 9%. So hopefully we'll know soon if the actual fix worked. In terms of sync time, it's pretty much the same, but we hope it will be able to go over the blocks that were causing issues with memory limits by doing some hefty changes to reduce the memory allocations that are required to process the batch updates for the later. But yeah, we'll know more hopefully in 1 day or two, and if it works, we will be pushing it to production as soon as possible. That's pretty much it for Protocol Watch. I don't know if Paka is here. It doesn't seem that way, so I'm gonna hand it over to Abel now.
Amazing. Thank you both for the sections there, and Pekka for the round of applause. Yes, so Pekka's not in the house, so we're going to move straight on to our open discussion. And today Pekka no pain, yeah, it's a sad day. I believe Pekka's off at some meetings, and I'm not sure where Pain is. Probably doing some work somewhere else as well.
Pain.
That's amazing. Oh my God, is that new? That's amazing. Oh man, we got to use that one. That's a creepy Pain soundboard. I love it. Yeah, exactly. Pain is getting a lot of love in this IOH. It's a shame he's not here to receive it, but I'll send him the recording after for him to enjoy. Okay, awesome. So we are very fortunate to have a discussion, and we have people from the Waku team who've joined us today to join in that discussion. We also have Petko from GraphOps, and also Pili from GraphOps here as well. So I want to hand it over to Guru from Waku, who's going to tell us a bit more about the protocol, and then also hand it over to Petko, who's going to tell us more about how we leverage it at GraphOps. So Guru, if you want to start sharing your screen and starting your presentation, that'd be amazing.
Awesome. I hope my screen is visible now.
Yes, we can see it.
Perfect. So yeah, hi guys, I'm Guru and I'm one of the co-contributors of the Waku project, and I majorly focus on developer relations. So moving ahead, Web2 communications do not preserve your privacy out of the box. So every time you interact on a Web2 application, you have this vulnerability of being eavesdropped by various factors. So your social graph and your private data can be exploited by centralized gatekeepers for the sake of advertising or any other kind of exploits. So your messages are linked to your IP addresses and other Web2 identifiers, which make it more vulnerable for mass surveillance attacks. And when you look at your IP address, it exposes a lot more than you think. So with the traditional Web2 messaging or Web2 data exchange platform, you can expect that the sender and the receiver details are de-anonymized, and also the location of the sender and receiver is also exposed. So apart from this, you also have private metadata related to the messages being exploited. So IP addresses, in short, can reveal a lot more than we actually think. And these information, as I mentioned before, can facilitate surveillance and can ultimately hinder the freedom of speech by censorship and other kinds of attacks against data. So this is not a problem just for chat applications, but this is pretty much the same in all the other use cases like gaming, marketplaces, location sharing apps, IoT networks, and anything that revolves around machine to machine or machine to human communication. So this is the exact spot where we wanted to make sure that data is not controlled by a centralized stakeholder, and it remains in control of the user who's sending and the user who is receiving it. And that's what we are doing at 𝗨𝗂. We are a family of robust censorship-resistant communication protocols designed to enable privacy-focused messaging for Web3 apps. We stick on to 6 main ethos at 𝗨𝗂. The first one being privacy. The whole 𝗨𝗂 architecture is privacy first, making sure that we have edge cases tested that do not reveal your information when you try to communicate with 𝗨𝗂. And the second one is censorship resistance. So 𝗨𝗂 also makes sure that users belonging to a particular geography or a particular group cannot be censored by a centralized authority. And 𝗨𝗂 is also modular, which means that it can stick on to any blockchain. It's blockchain agnostic, and it doesn't care about blockchain the application is using. So it's something that can actually complement a blockchain. That's how we define 𝗨𝗂. And it's adaptive across a range of devices and resource environments. And it's also securely scalable, which means that we do not compromise on scalability and performance for the level of decentralization. And finally, 𝗨𝗂 is also DOS protected. No one can carry out DOS, denial of service attacks, over the 𝗨𝗂 network, making it unserviceable. So these are the 6 main characteristics that we wish to stick on to at 𝗨𝗂. And going ahead, again, 𝗨𝗂 is not a blockchain, but it's something that can complement a blockchain. And 𝗨𝗂 is not just a chat messaging protocol, and it can be used for various use cases which revolve around generalized communications. So some of the use cases can be gaming, marketplaces, and anything that requires communication between machine to machine or machine to human. Going ahead, talking a bit about history. In 2013, Ethereum white paper was introduced, and the Holy Trinity of decentralized web was coined. The Holy Trinity was Swarm, Ethereum, and Whisper, where Ethereum was meant for the consensus, and Swarm was more preferable for storage, and Whisper was the generalized communication protocol. And all these 3 together was formulated as the Holy Trinity of Web3 in the Ethereum white paper. But over the years, there were not much of dedicated teams building on top of Whisper and Swarm. And it was only in 2020 when 𝗨𝗂 v1 replaced Whisper in the status app. So 𝗨𝗂 is an iteration of Whisper. We had various architectural changes. We had a lot of design changes happen in the protocol. And 𝗨𝗂 v1 was a better enhanced protocol when compared to Whisper. And the change happened in 2020 when status app migrated from Whisper to 𝗨𝗂. And today we are rapidly evolving as the standard of Web3 communications, and we are trying to position ourselves as a public goods project, which any project can adopt. So this is about 𝗨𝗂's history. And 𝗨𝗂 in a nutshell has 2 main segments. The first one is the 𝗨𝗂 protocols. We have a family of protocols which can be useful for developers to build various use cases in your mobile apps or your desktop apps, or anything that revolves around clusters or web applications. We have endless use cases. And we also have Waku Network, which is an opinionated network that we are trying to build to make Waku batteries ready and more like a plug and play style. So digging deep into it, a quick introduction about Waku protocols. We have a lot of protocols under the Waku hood. So I'll just be highlighting about 3 protocols for today. And the first one is light push, filter, and store. So all the 3 protocols are light protocols. So it's similar to the Ethereum terminology. They can work on resource restricted devices. And all the other protocols are mostly focused towards relay nodes and resource rich devices. So the purpose of each of the light protocol is different. With light push, you can send a message into a content topic, and filter can help you subscribe messages from a content topic, and store is a temporary storage for persisting your messages. So Waku is not ephemeral out of the box. So we don't have data storage in the network automatically unless you prefer to use store, which is the centralized part of Waku right now. We use a PostgreSDB to store all the cache storage of the previous messages. So this is all about store. So I'm sure content topic should be an alien term to a lot of you, at least a few of you. So content topics are nothing but namespaces within the Waku network. We filter out the messages based on content topics. So one particular Waku node can connect to a specific content topic, but it is highly interoperable, so it can communicate across other content topics as well. The way we define content topics is this specific template, which has the application name followed by the version, followed by the content topic name, and finally the type of encoding that is being used. So a perfect example for this would be supercrypto, which is the application name, one for the version. Notification is a category of messages that you can position, and then finally proto is the type of encoding that we use. So this is a example for a valid content topic. So another property of Waku, as I mentioned before, is Waku can cater to all resource environments, starting from less resource environments like browsers, mobile phones, to high resource environments like clusters and VPS servers. Now let's just try to brush up what we've been looking at. So light push is used for sending a data object into content topic, and then filter can be used for retrieving data from a content topic, and finally store is a temporary storage protocol. So moving ahead, this is an example of a data packet. Each and every data packet is addressed by a content topic, followed by the payload, which actually carries the message data, and some meta tags and additional attributes that can be used for application specific processing, and also the timestamp when the message was sent. Finally, we have an ephemeral property. This can be a Boolean, either true or false. So if it's true, the message is going to be stored in the Waku network temporarily for a specific set of days. Right now it's 30 days. So if you set ephemeral to true, we are going to use store protocol for storing it for 30 days. So finally, we also have, so Waku network, one of the best things about Waku network is anyone can run a node and contribute to the network. There are a lot of other communications protocols in the space, but it's mostly the nodes are federated in-house. But with Waku, we let anyone run their own Waku node, which is an NWaku implementation, a NIM implementation of Waku node. And you can do it by just running a Docker compose command. And for further instructions, you can find the instructions for running the node over here. If you want to know more about our opinionated Waku network, we also have an RFC for this. It's on our research article, and you can go ahead to know more about the Waku network as a whole. So just a simulation of how fast a message of 2 KB size is getting sent across various Waku nodes around the world. So it starts from Singapore, goes to Delhi, and New York, and then finally reaches Frankfurt. And all this happens in a few seconds, and the latency is definitely competitive to something in Web2 communications. So this is a quick uh, simulation of real-time simulation using real machines around the world. For you to know more about Waku, I have three main resources. The first one is the documentation, which has guides for using different protocols in the Waku family of protocols. And we also have some code snippets to make it easier for you to build with Waku. And we also have some project ideas and inspirations that you can check out with Waku. The ideas are available at ideas.waku.org. We have around 80 ideas that we want developers to build at hackathons and other coding events. So if you have more ideas, feel free to create a PR and we'll get it reviewed. And finally, you can also head to our awesome Waku repository to find our links to workshops at various Waku hackathons and conferences. We also have a list of all the 85 projects that use Waku right now. And all these projects are from different hackathons and different conferences around the world. So I also take this time to spotlight a few projects just so that you can understand more about Waku and where Waku can be used. So the first project that we love from the recent hackathons is Block IoT. It's an IoT system that communicates using the Waku protocols. So you can basically connect a new hardware into your system, and then you can track various metrics from your hardware. And it's pretty interesting because there are very limited projects that integrate hardware into Web3 protocols. So I find it to be personally exciting. And we also have an application called 𝗨𝗂𝗂𝗧 from 𝗨𝘀𝗀𝗧. They are a privacy preserving wallet-to-wallet location sharing app. So this can be an alternative to traditional location sharing in Web2, which involve Google services or Apple services. 𝗨𝗂𝗧 makes sure that it's peer-to-peer and you don't have to have a dependency with a centralized stakeholder. We also have a couple of games built with Waku. One of the recent ones was a Battle of Cards, which is a simple multiplayer card game built with Waku. So it's also live, so you can check it out at Awesome Waku repository and give it a go to understand how fast Waku can be. And recently we had a project called Mr. Fox, which tried to use Waku as a middleware for LLM models. So the problem that exists with LLM models right now is, especially for some centralized entity like OpenAI, they collect your data in the form of prompts along with your identifiers. So whenever you search for something, in ChatGPT, your prompt is getting linked to your identifier, like your email address, and it's going to be stored on their in their machine learning processes, and they're going to be using this data to train the model more, which makes sense. But the fact that your identifier is being linked to the data does not make sense. So that's where Waku steps in, and it's basically a middleware which can decouple the identity from the prompt. So that way, ChatGPT or any centralized LLM platform will not know who the prompt is coming from. And this is definitely really useful. And we are already talking to a couple of AI X Web3 projects who are interested in exploring this use case. Awesome. So finally, the CTA for this presentation would be our documentation side. So you can learn more about Waku conceptually by going to this specific link. And if you have any more questions to the Waku community, or if you want to stay updated with our community and ecosystem updates, make sure to join our Discord. It's at discord.waku.org. We got more than 1,500 Waku contributors over there, and we share all our updates over there. So after this, I think I'd let Petko speak about how GraphOps leverages Waku, and I think it's a really cool use case, and it's probably one of the first use cases which uses Waku to decentralize indexes. And I've been looking at a lot of similar projects these days, but they have a heavy dependency on centralized infra, And that's where I find GraphOps to be solving a very big problem, which is decentralizing the indexes, and it's really inspiring. So I'd let Petko share a few words about how GraphOps leverage Waku for decentralizing the indexes.
Awesome. Thank you, Guru. I think that was a great presentation. Just to say a few words. We've spoken a lot about GraphCast and Subgraph Radio on previous IOHs, but basically we use all of the cool technology that Guru just highlighted in order to make messages between indexers and, of course, different network participants in the very near future, mainly subgraph developers and maybe even delegators at some point, in order to make sure that messaging within the graph protocol is decentralized, efficient, fast, secure, and all that good stuff. I really don't have much to add over what Guru said, but I hope now you're as excited about Subgraph Radio and GraphCast when you know what the tech beneath it does.
Right, I think I have some questions lined up on the chat box. I can take a couple of them, and maybe I can take the others one-on-one on our Discord, or feel free to ping me up. But the first question that I see is, what is the difference between Waku and plain libp2p? I think this is definitely a important question for any project considering the right communication stack for your project. So the biggest difference is Waku provides you a network and libp2p just provides you a set of protocols. And with Waku, we are a service network built on top of libp2p itself. So we use Gossip Sub for routing our messages. So that way we still use libp2p. And you can definitely use libp2p natively, but I think the biggest friction point that Waku is trying to solve is the developer experience, first of all, and also the batteries ready form of the network that you can utilize. So you can just plug Waku and use our SDKs to get started without having to worry about shared infrastructure. So I think this is the most important difference between Waku and libp2p. But yeah, there are also other differences, like with libp2p, it's not privacy preserving by default. So with Waku, we are privacy first. So every time there's a state change, or every time there's a state change in your Waku message, or every time you send a message, your peer ID is going to be changing up. So the peer ID is dynamic, and you cannot expect the peer ID to be same, which is not the case with libp2p. So this makes routing the messages with Waku a bit more challenging, but that's all about the main principle of the protocol, keeping it privacy first. And we also have rate limiting nullifiers, which is the way in which we implement decentralized and privacy preserving rate limiting for the whole network. So again, it's first of its kind, and we are one of the first projects to implement RLN in production. So RLN is an exciting technology from the privacy scaling explorations team in Ethereum Foundation. So it's really worth exploring if you're into decentralized DOS protection algorithms. So yeah, that's my answer for the first question. And yeah, Waku is a great option for low bandwidth devices. Petko mentioned in the chat. You can run it in a device like Raspberry Pi, and you can still run an Waku node in a Raspberry Pi, and you can also run it in a VPS server. All right, the next question. Oh, I don't see any more questions. Can someone point me up with other questions if there are any?
Yeah, there should be. Let's see. So, just under the one you read on what's the difference between WACU and plain libp2p, any hierarchy settings from state machine, and he goes on to ask more about his question. I may have missed that, but did you respond to that one below?
Oh, not really. I'm just looking at it right now. Thanks for spotting.
Perfect. Yeah.
Yeah, so the question is revolving more on customizability of Vaku. So right now, I can be more, I can answer it on a more general note, I would say. So right now, a lot of projects are using Vaku in a way that they customize a lot of things with Vaku. For example, the message throughputs and even the number of messages that can be sent per second from a client. So right now we have a limitation of one message per second for the Vaku network at least. But when you run your own fleet of Vaku nodes and federate it on your own, you can customize all these things, and you can also run Vaku fleets by yourself, which is how a lot of projects like Railgun, the Graph, I believe, and also XMTP are using Vaku. So in the long run, Vaku network is going to solve a lot of other problems that our partners are facing right now, like rate limiting, for an example. So right now, it's highly customizable. There's no vendor lock-in. You can spin off your own Vaku network anytime if you want to, get offboarded of the Vaku network itself. So yeah, I think that should be a more general answer for the question. And and also there's another part of the question which says about routing to anchor nodes. So also this one is customizable, but I'm not sure about the exact number, but it's definitely on our protocol and network RFCs in vac.rfc.dev. That's where you can find more about this, the exact numbers. But even that should be customizable. You can, customize the whole routing procedure if you're trying to, play around with NVACU. Coming down for more questions. Yeah, I have another question which says, speaking of privacy, did I hear you mention that IP addresses are hidden or obfuscated? So with Vaku, definitely, like we don't expose the IP address of the sender or the receiver. So it's just the concept of namespaces where every time you send a message into a namespace, your IP address is decoupled, and the receiver is going to be a couple of filter nodes who are listening to a particular content topic. So Vaku is architectured in such a way that you don't expose your IP address at any of these actions. So the follow-up question is it impossible to tell who is subscribing or pushing on specific channels? Yes. So by Vaku as a default, we don't have any identifier linked to your light push or filter clients. So even the node ID is going to be, the peer ID is going to be dynamic. So it's not going to be static by default, but you can still play around and make it default based on your use case. And there are some, applications like Status itself who use Vaku for wallet to wallet messaging, which means that they have identifiers like wallet addresses. So it's wallet to wallet, and the person who is sending a message to another wallet knows the receiver. So this is also possible with Vaku. It's totally depending on the use case, but on a low level, you don't necessarily have to, have an identifier or an IP address to send or receive messages. The next question is, how does Vaku handle DOS and spam? So yeah, talking about rate limiting and spam protection, these are two different things, and Vaku provides rate limiting, but not spam protection. Like, for example, someone can still send a scam URL or a link to a phishing site over Vaku, which could be potentially spam or a scam. But where we leverage RLN is for rate limiting. So for someone to send, let's say, 1,000 messages in a second, it's not possible. Traditional Web2 communication protocols and also other widely used Web3 messaging and chat protocols currently have static numbers for rate limiting their users. Like they set the maximum messages per second to a certain number, and that's how Vaku network is being operated now as well. But we have a proof of concept approach, which is RLN, which can basically make sure that no one can ping or get the Vaku network down by sending a big chunk of messages. So this is possible by attaching a zero knowledge proof along with every message that you send on Vaku. So the way in which it works is we have I'll be short about it, but then we have a membership contract deployed on the blockchain. And this membership contract can generate RLN memberships. And all the users who are going to push or receive messages are going to attach a proof whenever they send a message. And this zero knowledge proof will be validated in the Vaku side, and we'll be able to figure out if the message is spam, where spam doesn't mean that we are restricting a specific context of the message, but more like any message that crosses the rate limits is terminologically called spam, at least for Vaku. So yeah, that's how we implement RLN with Vaku. It's pretty challenging right now because we don't have any ecosystem players using RLN right now, but we have active dog fooding going on internally, and we are trying to implement RLN within our SDKs. But on a network level and on a node level, we have quite a lot of things in regards to RLN implemented. All right, so the next question is, what's the next big update from the team? So yeah, definitely RLN is, we've been talking about it a lot in the last couple of months because the whole team is definitely excited about it. It'll be a breakthrough not just for Vaku, but I feel it'll be a breakthrough for all the networks as a whole in the Web3 ecosystem, because right now we've been seeing a lot of blockchains going down. Even though they provide you high TPS and high benchmarks, the availability or the DOS protection stuff is not yet figured out by a lot of projects and networks. So I think RLN, Vaku dog fooding, and preparing feedback about RLN is really cool, and that's something that we've been working on for the last couple of months. And apart from that, we're also working on sharding for making sure that Vaku is more scalable. Right now we are using static sharding, but then auto sharding is also something that we're really looking at in terms of scalability. And we have a lot of exciting, integrations going on, just like I mentioned with AI X blockchain projects, and we also have some deep in projects coming up that are interested in Vaku. So we are trying to support all the projects in terms of integrations as much as we can, and you can definitely expect a few announcements in the next coming weeks with more projects shipping live, shipping Vaku in production in their projects. Cool. Looking for the next question. I'm going to send my link to the slides right after this call, so I'll make sure to do that. What are the limitations and risks associated with Vaku? So keeping the technical or more deeper risks aside, I think Vaku is rapidly changing in terms of developer experience itself. So we are experimenting a lot with our SDKs, and there's a lot of work going on around the way in which we offer Vaku to developers. So for any project that is currently looking to integrate, make sure that you are in contact with the Vaku team to understand the roadmap, what are the potential migrations that you'll have to do along the way. And we're trying to, so the SDK that we have right now, at least the JavaScript SDK, it's most focused towards protocols. Like you'll have to know more about the Vaku protocols to implement the Vaku SDK. but we are trying to simplify it and abstract it a lot by making sure that it's targeted functionally. So you just have functions like as simple as send message, receive message, and then connect to content topic. So this way you don't have to know about the protocols. So this is something that we are trying to solve at Waku. Cool. Looking at the next question. What are the roadmap in terms of development? Cool. So the development roadmap, as I mentioned, is to get a pre-alpha for RLN for light clients like JavaScript. We also have other implementations like Rust bindings and Go Waku for Golang developers. So we also have a lot of other implementations which are not as actively maintained as JS Baku, I would say, at least from a personal perspective. So I think providing more support to these implementations is definitely in focus. So we are actively working on gathering feedback from different teams. And thanks to the GraphOps team for giving us a lot of feedback about the Rust bindings. I think we have very limited number of projects which use Rust bindings. I think, especially with GraphOps, the feedback was really important to us to decide on how we should position the implementation, if we should work more on it. And there's a lot of PRs happening across GraphOps and Waku. So it's a shared effort towards dogfooding this amazing implementation with this amazing project. Awesome. So looking at the next question. Yeah, absolutely. I think it's just a matter of time until RLN is battle tested. So once RLN is battle tested, I definitely look forward on behalf of the other Waku folks as well. We are ready to offer you support technically and in any ways possible. The biggest challenge is going to be, writing down the roadmap for the integration, because we don't have any testimonials or previous experiences with RLN integration with other projects, but it's going to be the first of its kind. And yep. What are the prerequisites for running a Waku node? So for running a Waku node, it's pretty simple with the Docker compose command. You just have to run the Docker compose command, and then it should set up all the dependencies along with a Grafana dashboard, which can help you monitor the network. So yeah, the Docker compose is the easiest method. Alternatively, you can also use the binaries to run the Waku network. Run the Waku node. And we have different types of fleets for developers to build on top of Waku. We have a bootstrap fleet, which basically helps you to connect to a bootstrap fleet that we've set up just for the sake of development. So the bootstrap fleet doesn't use RLN or the Waku network right now, which makes it more friendlier for developers. But definitely you'll be facing a lot of issues in terms of developer experience when you try to use RLN or the Waku network itself. But we are actively addressing these issues to make sure that it's usable in the next quarter at least. Next question I have is, how will Store be decentralized? So Waku, as a family of protocols, we focus more on the transport layers over other utility segments like storage, cache storage, which is basically the store protocol. And we also have other segments like access control. So a lot of developers that I've been personally talking to, especially today at DAppCon, they mentioned that it'll be really nice to have a kind of access control built in within the Waku SDKs. So since Waku is open by nature, anyone can send a message to any content topic, making it very vulnerable to send information on content topics without encrypting it. So that's where we would be exploring options to have some encryption standards or a library like lit protocol or threshold or some sort of cryptographic encryption library to be implemented within the Waku protocol, so that you don't have to do much of work when you send message on a public content topic. We are also working on private content topics. That has been something that we've been chatting with a lot of devs at hackathons. So yeah, we have a lot of proof of concepts for the same, and we're just trying to validate all these solutions to understand which is going to be the best. But for storage, at least right now, I personally would prefer people to use something like IPFS or Filecoin to store their data on a long-term basis, because store is temporary storage and it's going to store your data only for a span of 30 days. So having something more battle tested like IPFS is going to be a solution for now. But if you want to explore more about other alternatives, we also have a project within our family, like the collective that we are building in, called Codex, and it's basically content address storage, similar to IPFS, but it has a lot of pros and cons. So you can know more about it in codex.storage. But on this opportunity, I also want to shill out a couple of projects within our ecosystem. So this is basically the umbrella organization where Waku and a lot of other projects under the Waku ecosystem is at. So it's called the Institute of Free Technology. You can head to free.technology to check out all these projects. But we have a network state collective called Logos, which aims on movement building for network states, and it's basically a stack of network state related projects like Waku. And we have Waku, which is the communication layer. We're trying to build a P2P communications a layer for generalized communications across the blockchain ecosystem. And we have other interesting projects coming up within our ecosystem, like Codex, which is a storage solution, like I mentioned before. We also have Nomo, Status, Keycard, Nimbus, and a lot of other projects that you can check out. So I just want to make sure I complete this quick. So head on to free.technology to know more about this. And we also have an exclusive video interview with Petko from the GraphOps team, where we discuss in deep about how Waku is being leveraged by GraphOps in GraphCast. So make sure to check out the Waku YouTube for this video, and it's definitely worth checking out if you're planning to explore the technical aspects of Waku in a deeper note. So yeah, I think that's pretty much it. Oh, finally, I can take the final question. This is, how can we contribute to the Waku project? So all the code bases in Waku are open source, so you can find all the implementations available on our Git. So feel free to raise a PR. We'd love to see your PR. And we also have some bounties for hackers. The bounties might be paused for a little while, maybe for the next couple of weeks, 1 or 2 weeks, but then we are planning to resume it really soon. And the bounties are really good place for you to work on Waku or experiment Waku, while also you make a small bounty out of it. So you can know more about bounties at bounties.waku.org. I think we have around 2 to 3 active bounties, and we'll be listing more about it in the coming days. So that's all about it from me today. And if you have any more questions, feel free to join our Waku Discord or DM me personally, and I would love to chat more. And if you're around Berlin for the next week, or if you'll be in Prague for the first week of next month, please reach out to me. I'd love to say hi. And yeah, we also have some cool swags to give out.
Amazing. Thank you so much. Really appreciate giving all of that context there. Before we wrap, I was just trying to look for the Waku YouTube channel so that I could find the interview that you were mentioning, but I got a 404 when I went to this link that I just pasted in the chat. Do you have a link to the YouTube channel maybe so we can share the interview with people?
Yep, I'm going to send it right away in a second.
Amazing. And then feel free to send me the slides as well, and then I'll add them to the agenda so people can check it out post call.
Perfect. Yeah, I just sent the link to the video in the
Amazing.
chat, and
Amazing.
all right, thanks for having me today, and looking forward to deep dive more into the RLN use cases and see if the graph can be a potential fit for dog fooding RLN together.
That would. There you go. We love that. We love a good round of applause. Thank you very much for coming along and sharing all the information there. It's going to be very exciting to explore what the future looks like, and would be open to having you back on here again to discuss what that looks like as we progress. Thank you very much, Guru, and thank you all for everyone for joining in today's conversation. We hope you learned something. We've got a bunch of links here in the chat, and I will post the. Oh, there we go. The slides are in the chat. Even better, even better. I'll also post them to the agenda so people can find them easier. But there you go. Those are the slides. Yeah, like I said, we hope you found this very interesting. We hope you learned something. Unfortunately, Payne isn't here, but we have put a secret word in his name, which is no-pain-no-gain, no pain, no gain, which we want to thank Pili for. She's a mastermind when it comes to coming up with these secret words, and we love it, so keep it coming. Alrighty, we look forward to seeing you all again next week, same time. In the meantime, enjoy the rest of your week, guys. Take care, everyone. Bye-bye.